Okay, so this is a section regarding the organic chemistry and molecular structure of organic compound. And the question is how many pairs of lone pairs electrons do you have in this molecule? And if you're looking at this molecule, there are nitrogen. And nitrogen has 5 valence electrons, and they can have 1 lone pairs, and forming 3 sigma bonding, or they can have double bond and single bond can have a lone pairs. So this is a case that you can think about how when they can have for the heteroatom like nitrogen, they can have one lone pairs. What about the oxygen? Oxygen, as you remember from your water, they can form 2 sigma bonding, and then they have 2 lone pairs. That makes them to have essentially 6 valence electron can be used to form 2 sigma bonding and 2 lone pairs, and so that makes it 6. And what about oxygen? Can also form double bond with 2 lone pairs there. And in those cases of 2, actually the atoms nitrogen and oxygen hybridization is actually the sp3, because 1 lone pair 3 bond or 2 lone pairs and 2 bonds. Whereas in this case you only count the sigma bonding for hybridization. You have 2 sigma bonding and 1 lone pairs, or the 1 sigma bonding and 2 lone pairs, so that's a sp2 hybridization. Okay, so this is now let's have a look at this molecule, and by looking at it, you can see, okay, there is 1 lone pair, there are 2 lone pairs here, lone pairs there, lone pairs should be there, and this one. So if you start to count it, 1, 2, 3, 4, 5, 6, 7, 8 pairs of lone pairs, and this is the answer for this is number 8. Can anyone make a guess on this molecule? What do we call? And this is chemical compound is called caffeine. Okay. Please remember, when you see this at the end, that means you have a CH3 used at the end. This is a compound called caffeine. Okay, so this is a IUPAC naming an organic compound that you have. The thing that you notice is here is this is what we call the ester functional group, and an ester functional group coming from this organic acid moiety, which is you have a 2 carbon. 2 carbon means ethyl, so ethane, the ethanoate is coming from there, and then this alkyl group coming from the alcohol, so this came from acid, and this is part coming from alcohol, and this one is now counting 1, 2, 3, 4, 5. So this is a pentyl alcohol. So if you're putting them together, it's called ethanoate, and there are 5 carbons of pentyl ethanoate. The number is D. So that's the answer. This is under the IUPAC nomenclature system, and the IUPAC nomenclature system looking at this organic compound, and first recognize the functional group. So this is a alcohol functional group. It will say at the end. So from here, you start to count the carbon backbone. So this carbon connected to that, and you're trying to go either this way or that way. The answer is which one is longest here. Okay, and it doesn't matter which way you go. So I would just choose my backbone to be going this way. So that then make up your basic backbone. Okay, backbone you have is 4 carbon, with OH group. And how do you call this? This is we call the butanol. Right? Butanol, and the alcohol is in the position of first carbon. So this is a 1 butanol is one what we can say. So now because this is a carbon number 1, that became carbon number 2, this one carbon number 3, that became carbon number 4. In the carbon number 2, this ethyl is attached to the carbon number 2, so that makes it that makes it 2 ethyl. So bring these two together, you will get 2 ethyl, 1 butanol. That's the answer.